All right, today we're going to tackle a huge topic, something that's really at the crossroads of cool tech and, well, some pretty serious risks. I'm talking about the cybersecurity of autonomous vehicles. You see, as our cars get smarter, they're basically turning into complex, connected computers on wheels. And that means the threat of them being hacked, it's not science fiction anymore. It's a real-world problem with some very real consequences for our safety. Just let that sink in for a second. They could stop the car remotely on the highway. That's a direct quote from a huge security research paper back in 2015. And, this wasn't some hypothetical lab experiment. These researchers actually proved they could take over a Jeep's critical systems, the steering, the brakes, while it was moving, on a public highway. To say this sent shockwaves through the auto industry, well, that's an understatement. It was a massive wake-up call. And this is what that complete loss of control actually looks like from the driver's seat. What you're seeing here is the instrument cluster of a hacked car. You've got warning lights going off everywhere, the speedometer is just lying to you, it's total chaos. This isn't just code on a screen. This is the very real, very scary result when a car's digital brain gets hijacked. Okay, so how on earth does something like this even happen? Before we can talk about building defenses, we first have to understand the offense. So let's do that. Let's break down the anatomy of an attack. This framework here is super helpful. It comes from a massive study where researchers reviewed something like 150 different papers on the topic. And what they did was create this sort of roadmap of all the ways a car can be vulnerable. It neatly breaks down all the potential attack surfaces, from the car's own internal computers to its sensors, and even how it talks to the outside world. The big takeaway? It's not just one weak spot. It's a whole building with a lot of different doors and windows a hacker could try to open. So all those threats pretty much fall into three main categories. First up, you've got the automotive control system. Think of this as the car's brain and central nervous system, all its little computers, the ECUs, and the network that lets them talk to each other. Then you have the autonomous driving components. These are the car's senses, right? Its eyes and ears, the cameras, the LiDAR, which is kind of like radar but with lasers. The problem here is they can be tricked. And finally, there's VDX, which stands for vehicle-to-everything communication. This is all about the signals the car is constantly sending and receiving from, well, everything. Other cars, traffic lights, the cloud, you name it. All right, so I know that all sounds pretty complex, maybe a little scary, but here's the good news. For every one of those attack methods we just talked about, there are really smart people working on a defense. So let's switch gears and look at how we build the digital fortress to protect these vehicles. And just like we had a framework for attacks, there's one for defense too. It really boils down to these three main pillars. It all starts with a strong security architecture. You have to build security in from the very beginning. Next, you need a solid intrusion detection system, which is basically a burglar alarm for the car's network. And then, the really cutting-edge stuff is the third pillar, using AI and big data to actively hunt for threats before they can do any damage. Let's zoom in on that middle pillar for a second. The intrusion detection system, or IDS. This part is absolutely crucial. You can think of it as a security guard that is constantly watching all the digital conversations happening inside the car. It's looking for anything that seems out of place or malicious. So if a hacker tries to sneak in a command like, I don't know, turn off the brakes, the IDS is the thing that's supposed to sound the alarm and stop it in its tracks. But, not all these digital alarm systems work the same way. There are really two main flavors. On one side, you have specification-based systems. This is like having a bouncer at a club with a super strict guest list. If a message shows up that's not on the list, it doesn't get in. Simple. It's fantastic for stopping attacks we already know about. On the other side, you've got anomaly-based systems. This is more like a detective. It spends its time learning what normal looks like on the car's network, and then it flags anything at all, that seems weird or out of the ordinary. And this is huge because it means it has the potential to catch brand new attacks that no one has ever seen before. Okay, so securing one car is one piece of the puzzle. But what happens when there are millions of these things on our roads? How do we make sure the whole system is safe? Well, that's where you have to zoom out from the nitty-gritty tech and start looking at the big picture, national policy. And that is exactly what the U.S. Department of Transportation is trying to figure out. In fact, these graphics you see here, they're pulled right from the DOT's big comprehensive plan. It's all about creating a high-level strategy for how we're going to safely roll out all this new technology. And this is their guiding vision. It's pretty straightforward, but really powerful. Prioritize safety while preparing for the future of transportation. The key word there is prioritize. They're making it crystal clear that safety isn't just one item on a checklist. It's the number one thing. And that philosophy is what drives all the rules and recommendations they come up with. So how are they planning to do that? Their whole plan really comes down to three main goals. First, they want to get everyone talking: the government, the car companies, and us, the public. It's all about collaboration and being transparent. Second, they need to update the rulebook. A lot of our current regulations were written for, cars that don't drive themselves, so they need to modernize things. And third, they have to get the whole system ready: the roads, the communication networks, everything, for this massive shift in transportation. Now, having a big picture strategy like that is absolutely essential. But at the end of the day, the real fight against cyber threats happens on the front lines of technology. So let's zoom back in from the policy level and take a look at the really cutting-edge stuff in AV defense. And that brings us to what is, without a doubt, the future of this field. The next generation of defense is all about being AI-driven. We're moving past simple firewalls and rigid, pre-programmed rules. The future is about building security systems that use artificial intelligence and machine learning to think for themselves. Systems that can learn, adapt, and maybe even predict an attack before it happens. So what does AI in action actually look like? Well, here are a few examples. You have things called LSTMs. These are a type of AI that's really good at understanding patterns over time, so it can learn the normal rhythm of a car's network and instantly spot a message that's out of sync. Then you have deep convolutional neural networks, which are basically expert classifiers. You can train them to recognize the digital fingerprint of different kinds of attacks. There are also statistical models that can predict where the car should be going next, and if it suddenly deviates, it knows something is wrong. And maybe the biggest one of all, leveraging the cloud. By analyzing data from an entire fleet of cars, you can spot new kinds of malware or attack patterns and then push a defense out to every single car almost instantly. And all of this brings us to the big final question, doesn't it? Because at the end of the day, this is a constant, high-stakes arms race. As our cars get smarter and more connected, they become these rolling data centers, and the number of ways that can be attacked just explodes. So the real challenge isn't just about building a car that's secure today. It's about building a car that can defend itself against the threats of tomorrow that we haven't even thought of yet. The question is, can our defenses evolve fast enough to stay one step ahead? The answer to that is what will ultimately determine how safe our roads are in the future.